Okay, welcome back. We're going to have a look at the U substitution versions and see if we can't start to use those. Alright, so for question 1, so we can see that x is getting squared plus 9, then it's getting raised to the power 4. So like the chain rule, this is the clue that tells us that we're going to have to do 2 operations. So this calls for U substitution. So let's see if we can work out what we're going to be actually substituting. So we've got x squared plus 9. Now, students have indicated to me it's a bit confusing that we do integration and then differentiation when they're inverses, but what we need to remember is that this is of a form where the function is made up of a derivative and the function. And so what we're doing is we're taking advantage of this fact in manipulating the fact that there's a derivative. Okay, so we take out this part here. Now that's a quasi-statement, not to be taken literally. Okay, so now we can take our derivative of this, which would be 2x. Now we see that in the function there is 2x there. So we do our manipulations and simply we get du is equal to 2x dx. So by recognising that there is a derivative of a function with a function, we can cancel them. So that's what this U substitution relies on. So that we go back to this same idea, a U there, yep. A U there, yep. So both of these are now being replaced. You're gone. They're being replaced by du. So that for me is the scaffolding that represents an understanding of U substitution that you've been able to prepare it this way. This is now simply u to the 4. So we've simplified the integration. I mean, that looks horrendous at a first instance. This whole concept's a rather difficult one, okay? And look at it. It's now a very simple up and under. So we can go ahead and do the up and under, and we can see that 4 becomes 5. Oh, we're doing exactly what we did before. It's just that now we've got a bigger expression inside the bracket, x squared plus 9. So we rely on the fact that in doing integration, now if we go ahead and differentiate this, we will get our original function back. So I'll leave that as a check. Okay, a check would be to d dx, this thing. And you would have to use chain rule because of the 5. Constant would disappear, and this all of this would resolve back to being 2x squared. But I'll leave you to do that check. Okay, do that check. Alright, let's have a look at B. You can scrub the video and pause it if you want to spend a bit more time there. Okay, so for B, what's the decision that we have to make? Is there a derivative laying about? It's a bit like the quotient test we learned today, isn't it? Is there a derivative laying about? Kind of. Well, x is being squared and then it's being cubed, so it's having 2 things done to it, which implies that we should do the U substitution method. So staying in the column, not rushing off and doing a trivial substitution, gives us 2x. And look, we've done it again. There is 2 terms that are appearing in the original. There it is, a u there, yep. A u there, yep. So you're both gone by du. So that's the power of this particular technique. Du means something, and you'll learn that as you go on into Maths 1. You'll learn that there's other things you can do. when you're doing the u. Okay, so all we're left with is u cubed. Okay, so up and under again seems rather trivial, doesn't it? Yeah. Plus c. So we end up with 1/4 to the power of 4 plus c x squared minus 5. That's our final result. So there was not much of a decision because we were able to find both of those elements in the initial substitution, which is what I believe u substitution is all about. Okay? So it's all about that. Okay? So for part C, let's see what this turns up. You can stop the video and watch it to check the values there if you want to do that. Is there a derivative laying about? What's the form of the derivative? What manipulation have we got to do in order to facilitate a substitution? It's being two-valued function, f and g, so we need to use a u substitution. Okay? Now look at this carefully, please, because this came up in a question to me today. The u dx is going to be equal to 2x. The 4's gone. Now look at that form. If I put the dx up, I can see there's a 2x dx. Now, the question is, are you there? Yep. Are you there? No. There's only x there, so we need to continue on and divide by 2. So what you do to one side, you do to the other. So we end up with 1/2 du, and that's our substitution, x dx. Now go and check if they're all there. Are you there? Yep. Are you there? Yep. You're both gone, and you're both gone by this substitution. There you are, complete. Okay? So you've been changed out. So we manipulated the form of our substitution over in the column. So stay in the column. Okay, stay in the column. The trivial one now can be done. The trivial u is just u6. Easy peasy. Okay, so the trivial one is u6. So this means we get 1/2 up and under plus c, 2 7s are 14. So we'll have 1/14 to the power 7 plus c, and u itself was, so just putting the x's back in. And there's our final result. Very straightforward. Okay, so once you get the patterning and you get set, this becomes something that you can do readily. Okay, so we'll just keep going with it. We're up to, what do we do there? C. So we're up to D. So the integral, so we're looking for functions and their derivatives. Functions and their derivatives. Got any derivatives hanging about? x2 minus 2, that'd be helpful. Well, you're being chained anyway, so I've got to use a u substitution. Okay, x squared minus 2, staying in the column, u dx is equal to 2x, putting the dx over and asking the question, are you there? Dx? Yep. 2x? Nope. Further manipulation is required. So 1/2 du is equal to x dx. Are you there, dx? Yep. Are you there, x? Yep. So we're subbing you out, goodbye, and replacing you with this. Okay, and then the trivial, that's what I want all high schoolers to come out of high school with, being able to do that. Not this bit. This bit's the trivial bit. I can get a year 8 student to do that. Okay, so we need that. Alright, so up and under. U4 over 4 plus C. 2 4s are 8. So we have 1/8 4 plus C, and we had x squared And you can do these all on Wolfie if you want to check, or any particular system if you want to. That's fine as well. No problem there either. Okay. All right. So what else have we got? What was that? D. So now we can have a look at E, and we can think about that there. And for E, what have we got? 2x again. So we're looking for a derivative that's hanging around for 2x. Okay, is 2x hanging around? Okay, so let's see if 2x is indeed hanging around. So, in your formation, just go for it. Integrate 2x. Is there a derivative around? The square root. Oh, a bit of pre-work. X squared plus 10 dx is going to become x squared plus 10 to the power of a half dx. So we know that there's things being done. This time it's not being squared, it's being squared and square rooted. So we're going to let u equal x squared plus 10. U the x is equal to 2x. So if we put dx up and ask the question, are you there? The answer is, yep. Are you there? On this occasion, yep. So we're replacing all of u with u, and so we're left with this powerful substitution. U substitution. Wait a minute, what about the other u? Well, that's the trivial one. This is the one that says u to the half. No problemo. Now we can do up and under. Half plus 1 divided by a half plus 1 plus c. Now a half plus 1, it never goes away. We're going to have to add fractions every time we come to calculus. It's just not possible to get away from it. Okay? Sometimes you'll be able to do it in your head, and sometimes you won't. 3 on 2 times 2 on 3. So this will become 2/3 u to the 3 on 2 plus c, which is equal to 2/3 the square root, because the denominator is 2, and we've got a cube on the denominator, so this thing is raised to the cube, x squared plus 10 plus c. So that's your final answer, capital C. Okay, capital C. So once you get your pattern and you're making good decisions, these are very straightforward. Now we're kind of peaking here with this advanced course, and the only thing we've got to do next is do the ones with the numbers. There's a slight change at the end here. Instead of putting C, we do something else, but that'll be next week. So we'll be looking through a bit of that next week. All right, let's have a go with a cos x sine x to the power 3. Now, sine x is being signed and then it's being cubed, so we need to use a u substitution. We'll go inside the brackets, sine x, and so stay in the column, differentiating using Leibniz notation. Differential sign is cos. So putting dx up, du equals cos x dx. Now, are you there? Yep. Are you there? Yeah. Gonski, you're both gone. So the integration with respect to du, and so all we have is u cubed. Very straightforward. The pattern doesn't change. Stay in the column. Stay in the column. Okay? So this is going to become up and under on 4 du plus c, and ultimately that's a quarter to the power 4 sine x. Now those of you who recognise what to do with the power by convention, we could leave it like that because the question was in that form. Can recognise that's the 4th power of sine x, and that's your final result. Okay, so we get used to things. With time and patience, we get used to things. Okay, so the next one is g. So we've got the integral. And some of these look horrifying, don't they? It's like, wow, what's going on with this? Okay, but if we take our time and just recognise certain things, then we can go and use our training to kick in. So x is being caused, raised to the power 4. So this requires a u substitution, and it's cos. Stay in the column. U the x is equal to the differential of sine is cos. So the differential of cos is minus sine. So it's not a big deal, because all we do is ask our questions and make decisions. That's all. And if we do that, we can do it intuitively and fairly quickly. So dx u there you are, sine x u there. Is the minus there? No. So I've got to divide or times by minus, and so I'll get minus du. Now because I checked that question, I've made a change. Okay, are you there? Yep. Are you there? Yep. Well, you're both gone, and you're both gone by this substitution. Thank you. Okay, now we're left with a trivial substitution. The trivial substitution is in fact u4. So we can go along and do the integration, and we'll end up with u5 over 5 plus c. So we get minus cos x to 5, 1/5. Now I know there'll be people who'll say, shortcut, shortcut. No, 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 no. We're not finished yet. We don't do shortcuts, because I've seen students cry because the shortcut system didn't work and they had to learn it all again. Okay, after doing a few years of this at university, you might decide to throw in a couple of things by sight. But in the meantime, practice, 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 practice. Stay in your column and do your work. Okay? Alright, that's probably enough for now. I'll leave that at G, and I'll see you in the next video. Bye for now.